look at the idea of a rate of change. Statements such as the population is increasing at a rate of 100 people per year is a type of rate of change. It's telling how the population is changing in terms of time. And a rate of change is just looking at how something changes in relation to something else. And these occur in nearly every field. Most of these are actually the average rate of change. These look at how something changes over some type of interval. There are several different ways to think about the average rate of change. Here are 3 different ways here. The average rate of change is thought of as the change in the output divided by the change in the input. If we have 2 points, one we call x1, y1, and one we call x2, y2, then we would do y2 minus y1 over x2 minus x1. And the same thing but written in function notation, f of x2 minus f of x1 over x2 minus x1. There are a lot of examples of rates of change in everyday life. These can include a population of bacteria increasing by 40 cells per hour, a car traveling at 75 miles per hour, a car with gas mileage of 24 miles per gallon, or the amount of money in a loan decreasing by $200 per month. This table shows the average price of gas over several years. Let's suppose we want to know the average rate of change for the cost of gas between 2021 and 2024. We need to start by seeing how much the price of gas has changed between these 2 years. Subtracting 3.3 minus 3.01 gives us 0.29. Next is to see how much time has passed. 2024 minus 2021 is 3. Finally, we're going to divide these two numbers. 0.29 divided by 3, rounded to 2 decimal places, is about 0.10. So this tells us that between the years of 2021 and 2024, the gas increased an average of 10 cents per year. Next, let's look at the rate of change between 2019 and 2021. And this time, I'll do it all as a single step. We would subtract the outputs, 3.01 minus 2.60, and divide by the inputs, 2021 minus 2019. Calculating this gives us 0.41 divided by 2, which is about 0.205. So this tells us that between 2019 and 2021, gas went up an average of 20.5 cents each year. We can also determine the average rate of change from a graph. So let's consider this function here. Let's suppose we want to find the average rate of change between x equal to -1 and x equal to 3. If I go over to -1 on the x-axis, then I can see that the y value is also -1. If I go over to 3 on the x-axis, then I can see that my y value is 0. So we do the change in the outputs, we subtract the y's, divided by subtract the x's. When I do that, I have 0 minus -1 divided by 3 minus -1, which simplifies to 1/4. So my average rate of change between -1 and 3 is 1/4. Next, let's try to find the average rate of change between -4 and 1. If I go over to -4, then I can see that the appropriate y value would be 4. If I go over to 1 on the x-axis, then my appropriate y value would be 2. So we subtract the y's, divided by subtract the x's. This would give me 2 minus 4, divided by 1 minus -4, which would simplify to -2 over 5. So the rate of change between -4 and 1 is -2/5. An equation of a function can also be used to find average rate of change. Let's consider this function here, 3x squared plus 2x minus 1, and suppose I want to know the average rate of change between 0 and 3. The first step would be to find the values when you plug in 0 and when you plug in 3. When we plug in 0, we get 3 times 0 squared plus 2 times 0 minus 1, which is minus 1. And when we plug in 3, we get 3 times 3 squared plus 2 times 3 minus 1, which is 32. So finally, we actually need to find the rate of change. We subtract the outputs that we just found, minus the inputs that we were originally given. 32 minus negative 1 divided by 3 minus 0 gives us 33 over 3, which simplifies to 11. So the average rate of change between 0 and 3 is 11. Next, let's suppose we want to find the average rate of change between 1 and 3. We previously evaluated f of 3 in my last example, so I went ahead and left that one. But we do still need to find f of 1. That would give 3 times 1 squared plus 2 times 1 minus 1, which is 4. We then subtract these two outputs divided by my original inputs of 1 and 3. When we do that, we get 32 minus 4 over 3 minus 1, which would simplify to 28 over 2, or 14. So the average rate of change between 1 and 3 is 14.